Right, let's do this. So the next part of number patterns is now geometric. We've learned about arithmetic, yeah? We all know what arithmetic is. Chris, can you tell me what's an arithmetic sequence? Pattern? Yeah, it's pattern. What's the pattern though? Adding and subtracting by what? The same number. That's an arithmetic sequence. You're adding or you're subtracting by the same number. There's a lot of different type of sequences. I've seen sequences where you're adding and subtracting, but you're just adding the previous two numbers. And that's called a Fibonacci sequence. There's another sequence called a mix of arithmetic and a Fibonacci. Okay, it's a weird name. But the next thing we're going to look at, it's another basic one, is what we call a geometric sequence. Right, so your geometric sequence is not the same as adding and subtracting. It's a bit different. So for our learning intention today, I want you to understand how a geometric is different to an arithmetic, and then understand what is a common ratio. Okay, so we know what common difference is. Kane, can you remind me what was the common difference? You remember what's a common difference? So, yeah, but what are you doing? Adding and subtracting, yeah? Okay, good. What do you think a common ratio then might be? It's probably going to be multiplying or dividing, but by the same number. So it's still common. It's the same. And by the end of today, as a success criteria, I'd like you to be able to find or calculate your common ratio. Okay, so you know how to do common difference. Any term minus the previous term. Or it's a bit confusing when you're working with money, it's finding the percentage of something. But with common ratio for geometric sequence, it's similar. Okay, so we're going to learn about that. I want you to be able to create a sequence as well of numbers, so we know what that means. When you say create a sequence, list the first 5 numbers. That's all that is. And then I want you to make a graph for a geometric sequence. All right, so that's what we're looking at today. Quick recap. Here's our number patterns. We know what term is. Term number at the start, it's always T0. Just remember that. So in this sequence, let's fill this in. Cohen, can you tell me what is the first number? Or let's say, what's the starting number? Yeah, T0. 4. Good. Okay, 4. All right, and then the T2, which is over here, should be 16. Okay, and then T4 is 28 right there. Just be mindful of the wording, yeah? When it says first number, yeah, it technically means at the start. I get it. But it's also, just be mindful of what that means. All right, so just you have to be confusing. So A equals, in this case, 4. So I'll just leave it at that. All right. So we know we understand that. Also, we know what these are. I've kind of gone through a recap of it, so I won't go through that. But let's look at geometric sequences. So we're up to this slide here, which is slide number 43. So geometric sequence and how it differs to arithmetic is it's going to be a list of numbers where the next number that you're getting is basically, I did say division, didn't I? But just for year 10, we're just going to treat it as multiplication. Okay, you're going to be multiplying the whole time. It's always multiply, not division. Okay, and I'll tell you why later on. But in essence, a geometric sequence is when you're multiplying by the same number. So you're not adding or subtracting anymore, it's just multiplying. So let's look at this sequence. We can see that the starting number is 3, and from there to the next number, it's 6. Okay, so you can say it's gone plus 3 if you're trying to think of this arithmetically, but it's gone plus 6. So it's not an arithmetic sequence, is it? It's not adding anymore. So from 3 to 6, it's doubled. So it's times 2. From 6 to 12, it's also doubled. So it's times 2. And then 12 to 24, it's times 2. And then 24 to 28, it's times 2. So you can see that it's a common ratio of 2. It's multiplying by 2. Okay, so that's what we call that's what the number is being multiplied by. Now, I did sort of give it away. Okay, but that number that you're multiplying by, that's the same number in a geometric sequence is called the common ratio. So now it's called ratio, not difference. Okay, keep that in mind, ratio. So when we're talking about common ratio, it's the number that you're multiplying by. not the number that you're adding and subtracting. So don't get them confused, please. They're slightly different. So in this sequence here, I can see it's multiplying by 3 each time. So the common ratio must be 3. Okay. Now, the difference is when you're dividing, yeah, obviously your numbers will go down each time. But whenever you multiply with a number that is less than 1, it also goes down each time. That's why I mentioned before, with geometric sequences, we're just going to focus on multiplication. Because when you multiply with a number less than 1, notice how the number or the term just keeps decreasing each time. Okay, does that all make sense? So we're just going to be using multiplication for this one. So that's the common ratio. Okay, so the common ratio is the number you're multiplying by to get the next term. Okay, this is starting to lag. All right, so how do we then calculate the common ratio? Abby, can you remind me, how do we do common difference? How do you calculate it? Not the percent, well, just your normal common difference. Do you remember? Any term minus the previous term, yeah? So that's for common difference. But with common ratio, it's a similar process, but instead of minus, it's any term divided by the previous term. Okay, so for common ratio, it's any term divided by the one before it. So you could also look like this. That's also fine. It's the same thing. So for this one, in this example, for this sequence, we need to find the common ratio of it. This example is using T4 divided by, what's before T4? T3. So what's T4 here, Attila? 1296. So let's put that in. So it's going to be 1296 divided by Kane. What's the previous term? So if you got T4 divided by T3, what's the value of T3? 216. Very good. So again, it's the same as, or very similar to finding your common difference. It's just instead of minus, it's division. So 1296, you can do 1296 divided by 216, which gives us a common ratio of 6. So that means to go from one number to the next, you're multiplying by 6. Okay, times 6, times 6, and then times 6. Okay, that's all the common difference is. Ratio. It's pretty much the same concept. It's just multiplication now. So just understand how to get the common difference. A ratio, sorry, I'm going to get confused now, when you're doing geometric sequences. Alright, so I want you to try and do these ones on your own. So for this question, it says to state the first term, which it's already there, but I want you to find the common ratio for these two. You use the suggested terms. You can actually use any, because for this question, I can use, for example, T4 and then T3. That's fine, because it'll give me the same answer as T3 and T2. So if I get my calc, actually let's do T3 and T2. So it's going to be 337.5 divided by 225. It should be the same. 337.5. Let's confirm that. Divided by 225, which is 1.5. Or you can also use 3 over 2, but let's use 1.5. Okay, as our common difference. Ratio. And again, like I said, you could actually use anything. So I can use T4 if I wanted to. So 506.25 divided by 337.5, and it'll give me the same answer, or close to, which is 1.5. Thank you. There you go. Yeah, so it gives you the same thing regardless of what you use. This one here, okay, it's going to be, what did we use? T1 and T0. So 28.8 divided by 34.56. Shh, thank you. Can anyone tell me, is this answer going to be more or less than 1? Less. Good. Okay, so 28.8 divided by 34.56 gives us 5 over 6, or 0.83. That's fine too. Okay, both are correct. So I'll say this: you can use percentage. So you can use decimals or you can use fractions for your common ratio. That's fine. All right, let's go to the next one. All right, thank you. So remember, I kept making a note that whenever you do these questions, you have to show full working out. So when it says to list the sequence or list the sequence of numbers, first five numbers, then yeah, do it. Okay, so let's do this as an example. You've got T0, T1, T2, you've got 7, 14, 28. You can probably look at it and say, sir, it's multiplying by 2. I know it. Fantastic, but you have to show you working out. Okay, so let's do the common ratio. According to this, they wants us to use T2 and T1. Again, you can use any term. Just don't use T0 though, because there's no term before it. So I could go T2 and T1. That's fine too. But in this case, it's T1 and T0. But let's use T2 and T1. So it's 28 divided by 14. I don't need a calculator to do it. I know that the ratio is going to be 2. So that means each time it's multiplying by 2. All right. So in this sequence, it wants us to show what's T3 and T4. So T3 is going to be, and again, if you just follow the sequence, you know you're multiplying by 2 each time. So that means to get T3, it's going to be whatever T2 is times 2. So let's do the working out. So T3 is equal to T2 times the ratio of 2. The value of T2 was 28. So it's 28 times 2, which gives you 56. So that means T3 is 56. Easy. All right. And again, just following the sequence to go from T3 to T4, again, you're just multiplying by 2 because we know the ratio is 2. So it's going to be T3 times T2, times 2, which will be 56 times 2. And I think off the top of my head, it should be 112. Thank you. 112. So that means the value of T4 is 112. You must show you're working out when you do these, yeah? If it's like list out every sequence. But if it's only like tell me this number, you should be okay. All right. Any questions with that? Not hard, not hard. Easy. Oops, sorry. Okay. If you're finished copying that, can you please do the next two as an example? So do those two for me. I'll leave this up here. But do the next two as. All right. So for the first one, again, you're just finding the common ratio first. So again, any term divided by previous term. So I might go 12.1. I'll go 12.1 divided by 11. All right, so we'll start with that. 12.1 divided by 11 gives us 1.1. So the ratio is 1.1. So that means to go to the next number, we're just multiplying by 1.1. Therefore, to go to T3, you're just multiplying by 1.1. Not too hard. It's just too fat. All right, so in using that, to get T3, working out, you have to show it. So T3 should be 12.1 times 1.1. If you just show you working out like this, it's fine. You don't have to show every single step. That's too much. All right, so again, 12.1 multiplied by 1.1 equals 13.31. Okay, so 13.31. And then to get T4, okay, it's 13.31 times 1.1. Okay, again, same process, yeah? Point 1, which is 14.64. Okay, thank you. Again, you must show you're working out when you do these. Okay, you can't just actually do the work. You must show working out. Next one. Okay, this is, I can use any, but let's just use 729 divided by 810. Remember, it's any term divided by the previous. So if I do that, 729 divided by 810, 0.9, fantastic. Okay, 0.9, cool. So to get T3, it's going to be 729 times 0.9. And I'm going to do Abby's shortcut. Abby, tell me what your shortcut was. You wrote the first starting number, pressed enter, and then you multiplied by 0.9. And this should tell you, so that's 810 for T3. Oh, sorry, that's T1, my bad. T1, T2, T3, which is 656.1. And then T4 should be 656.1 times 0.9. So that's 590.49. Okay, so there's our answers. Easy. 656.1, 590.49. All right, any questions with that, guys? Geometric sequence, not hard. Same as arithmetic, just multiply. Okay, shh, thank you. All right, we're going to move on because we are running short on time. But let's keep going. Thank you. All right, we're nearly done, guys. Just a couple more things. Okay, just the graphing question, and then I think we'll be done. All right, come on, you tens, I'm waiting. Let's go through the graphing part of this, because the next thing we need to learn is how do we graph all this. So, just really quickly, when you look at the difference between arithmetic and geometric, you'll notice that, remember, arithmetic, because it's the same amount, you're just going to get a straight line. So it goes up by the same amount each time. With geometric, what's the difference here, guys? What's wrong? What's different with the line here? It's curved. Why is it curving? Tell me why.
The same amount is being multiplied.
Yeah, it's multiplying by the same amount. Well, it's more so that you're adding a different amount each time. And so each time you go, it's adding this higher number of values. So that's why it curves upwards. If it was the same number of values each time, it'll be straight, but it's not. Yes, Alana?
Is there going to be like a question that relates like with linear and arithmetic?
Yes, you might have one. Because linear is technically arithmetic, isn't it? Alright, so just keep that in mind. Arithmetic questions, your lines are straight. Geometric questions, your lines are curved. Alright, let's do this. We're nearly done. So for this sequence, we need to put the values in a table. We need to plot the graph and then describe the graph. So that's easy. So with these questions, guys, remember for the end, that's the term number. So we'll start with the start. 1, 2, 3, 4. Okay, that's what we're putting in. And then for Tn, that's what the value is for that number. So for T0, it's 7. T1 is 14. 28 for 2. 56. And then 112. Right, shh. Listening, please. Alright, that's not hard. Yeah, just fill in the table. Make sure you remember it's the same as arithmetic. Now we plot it. Okay, so plot the numbers. So for T0, it was 17. So 17 is probably about, 7. That's about here. That's all right. For the first one, it's 14. So if that's 10, I think 14 is about here. And what should the graph look like? Curved. Good. T2 is 28. So if that's 25, it should be about here. T3 is 56. So if there's 50, I think it's about here. Just above 55. And then T4 is 112, which is very high, about here. Okay, so notice the graph curves upwards. It's not straight. Okay, it's curving upwards. I can draw a line if I wanted to, just to really make it really obvious. So see how it's going to curve upwards. If you did T5, that would probably be like, I don't know, somewhere like over here. If you did T5, like up to here. Okay, but in this case, we'll leave it at that. All right. So how do we describe it? So in terms of describing it, we could just say the graph curves upwards. Because it's not linear. Okay, the graph curves upwards. Okay, not too hard. Alright, let me just say. Alright, cool. Alright, does that all make sense, guys? Does that make sense? I might actually stop there now.